Hello, so today we're looking at the consequences of climate change, El Nino and the Southern Oscillation. So what is the Southern Oscillation and why do we care about it? So this takes place in the Pacific Ocean and it's a regular oscillation or change between directions of a trade wind. So it occurs naturally and it's on a 2 to 7 year cycle. So this is something that will change regularly. So let's have a look at what happens under normal conditions. So under normal conditions, we have a reliable trade wind that blows between South America and Australia near the equator. So we have these sort of non-linear winds because of the Coriolis effect, and they push water from South America across the Pacific. As it travels across the Pacific, it warms up, and as it warms up, it causes lots of evaporation to take place. So we have warm water. And this warm water, as it evaporates, it starts generating clouds until you have loads of clouds over Australia and you end up with lots of rain taking place. On the other side of the planet, let's just label the trade winds first. Trade winds. And they are from east to west, which we say is westward. On the other side of the planet, of the Pacific, we have our South American coastline, the Pacific coastline. Obviously, South America is an enormous continent, so we're just talking about the coastal regions of South America. And this movement of water across the Pacific away from South America draws up water from deep under the ocean to replace it. So this is water that's under the water, like a long way deep under the water, and it's drawn up to replace it. Now this is very cold water and it is nutrient rich because it's been against the seabed for a long time. It's dissolved a lot of important minerals that would otherwise be limiting factors. This causes an algal bloom, which is lots of primary productivity taking place. So we have an algal bloom. And this means that we have lots of fish. So it's an important fishery for local communities. So it gives lots of jobs. What you also find, therefore, because it's cold water, there isn't much humidity. So we have a desert that runs along this sort of coastal region of South America. So let's put that a nice yellow color just to make it nice and clear. All right, so that's normal conditions. If we look at what's happening in a bit more detail on this coastline over here, so we have the continent of South America, and there's the ocean here. The wind blowing across the ocean provides friction, and this moves the surface water across the Pacific, or starts to move it across the Pacific. Now, to replace that water has to be drawn up from the deep. All right, so this water here comes up like this to replace it. You have lots of nutrients from the seabed being dissolved into this because it's in contact for a long time, and we call this an upwelling. So it's nutrient rich, which causes this algal bloom, which then feeds zooplankton, and then small fish, and then large fish, so fish. Okay, and you get the algal bloom at the surface because that's where the light is. So we're going to have lots of fish in here. And we're going to have lots of boats doing a bit of fishing. All right, and the communities on the coastline, because it's cold water, there's no evaporation, no humidity, so it's very desert-like. And these are the Andes mountains. Okay, so that's normal conditions. So what happens in an El Nino year? Now, for some reason that's not entirely clear, and it happens every 2 to 7 years, the trade winds will slow or even reverse. So our trade winds now are blowing in the opposite direction. This allows this pulse of warm water to return across the Pacific to South America. Okay, as it goes, lots of humidity, so we get lots of clouds forming, and we end up with floods and rain across the coastal region of South America. What we also find then is there's no humid air above Australia, so we end up with droughts in Australia. Because there is no movement of water away from South America, the upwelling stops, which results in a collapse in the fisheries. Because there's no more nutrients feeding that primary productivity or the algal bloom.